this activity is designed to help fill in some gaps on perhaps your understanding of the causes of climate change, and also to just provide an overview of climate change science and really hone in on the greenhouse effect and what scientists mean when they talk about feedbacks in the climate system or impacting climate change. You saw in the Earth System poster activity how connected all the different pieces of the Earth system really are. You looked at cloud cover and aerosols and biosphere and how connected all those different variables are. And that is really, really important to our understanding of climate change. Really, you can't understand the causes of climate change without understanding how the pieces interact and cause each other and feed off of each other and maybe cause feedbacks that are running out of control. So the first part of the learning activity today asked you to watch a video, an overview of climate change science. And if you haven't done that, press pause on this video and go back to the overview video that was produced by some very professional production, and then come back to this. If you have already watched that, you will remember that they talked a lot about the greenhouse effect, and I wanted to get a little bit deeper into what that really is, what it means. So you saw that they had the surface of the Earth on there for the greenhouse effect, and they talked a lot about greenhouse gases, right? And so here's the atmosphere. And they showed how the sun is, this is not to scale. They showed how the sun was delivering energy to our planet. And it doesn't actually deliver it. It's a passive process, right? We just happen to be in the path. And that energy is, some goes all the way through our atmosphere and some bounces off of clouds and stuff like that and is reflected back into space. And then the greenhouse effect causes, as the Earth's surface cools, the heat energy in infrared. And so the types of energy that are coming in are visible light, and ultraviolet radiation, and infrared. And the Earth's surface cools, and the greenhouse effect is causing that heat energy to be trapped, the infrared to be trapped. And so greenhouse gases, that's what the video said. The greenhouse gases cause it to be trapped. And I wanted to give you a formal definition so we have this working basis of knowledge of what is a greenhouse gas. So here we go. Greenhouse gas. The definition of greenhouse gas is a gas in the atmosphere that absorbs and emits infrared radiation. And the most common, I'm going to list out some of the greenhouse gases for you. The most common in terms of concentration in the atmosphere is water vapor. And our second most abundant is carbon dioxide. This is what the majority of our dialogue about greenhouse gases and climate change centers around. We'll talk a little bit more about that. And then methane, which here in the Arctic we talk a lot about. And ozone. Those are our four biggest greenhouse gases. And then some of the other ones that you may have heard of that we talk about when we're talking about climate change: chlorofluorocarbon, CFCs, and nitrous oxide, which is, so CFCs, that's the stuff that is released in the hairspray canisters and in the coolants of old-fashioned, back in the day, refrigerators. And nitrous oxide is often released through use of fertilizers. I think it's laughing gas. Also, I'll double check that. And so these gases, they all kind of vibrate when they interact with infrared radiation, and that allows them to absorb and emit. So here's a molecule, for example, a molecule of, it's not 2 scale again, of carbon dioxide, and a photon will hit, and it kind of vibrates, and then it will radiate that energy back down. And so a good deal of the energy remains trapped. A lot of people think that the greenhouse effect, oh no, it's bad, just bad, it's bad, it's leading to climate change. However, the greenhouse effect we would not have life on Earth without the greenhouse effect. We wouldn't have life as we know it, I should say, without the greenhouse effect. It provides a blanket that warms us from the cold, dark of space. So it is actually keeping our planet at a temperature that life as we know it can be sustained. What causes the problem, however, is an amplifying feedback. When the carbon dioxide in our atmosphere or other greenhouse gases exceeds the level of a stable level and causes more heat to get trapped than before. And that's what leads us to see this pattern of rising global carbon dioxide emissions and concentration, and the temperature correspondingly escalating since the Industrial Revolution. You can check out the graph. This graph is from the Arctic Climate Impact Assessment, and it shows in the back the shape of temperature change for the past 1,000 years, and it stays pretty stable up until right about 1800, and then it skyrockets upward in an exponential increase pattern. And then you can see the carbon dioxide concentrations are doing the same exact thing. And we look at our carbon emissions, and it separates out, in the green is land use change and the red is fossil fuel emissions. And we can see that right at our Industrial Revolution, our carbon emissions have skyrocketed, contributing to that increase in carbon dioxide concentration in the atmosphere and leading to temperature increases. So when we look at that escalating temperature and carbon dioxide figure, scientists explain that using the idea of an amplifying feedback. And a lot of people kind of get confused about a feedback, like what's a feedback? If you're a teacher, you give feedback to your students, and does it mean the same thing? And kind of, you give a feedback to your student and you say like, that wasn't quite right. And then the student can correct that, and it actually it balances the system, the knowledge gain or whatever you're trying to go for. In science, we talk primarily about feedbacks between different components of a system, and the Earth System Poster is a great introduction to the way that they're linked. But they can interact with each other and cause different loops. Scientists generally categorize them into 2 types of feedbacks: stabilizing feedbacks. That's where one thing changes and it causes another thing to change, but that change balances out the first change. And so it's a nice stable system. An example of a stabilizing feedback, here's one. Might be, you've got some plant system, and you've got soil, moisture. And if the soil moisture increases, got more of it, then it might lead to greater plant growth. So we know that plants, plants need water to grow, but not too much water, right? And then we know if the plants start to grow, then the more plants there are, the more soil moisture they're using for their growth. And so that can decrease the soil moisture the more plants that grow. And we've got a nice stabilizing effect where soil moisture and plant growth are kind of balancing each other out. Another type of feedback would be an amplifying feedback. And this is one really important for understanding that exponential curve at the end of the graph that we just saw. So we saw that we know that carbon dioxide is increasing in our atmosphere, which is allowing that greenhouse effect to have to hold greater amounts of heat on our planet. So that leads to an increasing global temperature. So the increasing global temperature could have effects such as thawing the permafrost. And we'll read more about this during our other activities in this module. Permafrost is soil that remains frozen for multiple years. And with increased temperatures, it could thaw. And if the permafrost thaws, that leaves soil and all the microbes and preserved carbon stocks able to decompose and release carbon back into the atmosphere. So with thawing permafrost, you could actually get more CO2 in the atmosphere. And with more CO2 in the atmosphere, that traps more heat within our atmosphere, causing the temperature on the planet to rise even more, which could in turn thaw more permafrost and cause more carbon. And so you can see this is kind of the runaway pattern that's known as an amplifying feedback. And we'll delve into more examples of stabilizing, amplifying feedbacks, other kinds of feedbacks between different parts of the Earth system and our own livelihoods in subsequent activities in this module. Right now, though, is your chance to ask some questions. What are you still wondering about after watching that video and learning a little bit more about feedbacks and the causes of climate change? What still is rattling in your brain? Now is your chance to tap into the scientists here at the University of Alaska Fairbanks that are on our Arctic and Earth Science team. Type in your question. This is your doing part, your assignment. Type in your question to our Google Plus community under the assignment section, and one of our scientists on our team will respond to your question. And if we don't know the answer, we've got some good scientists on our team, but if we don't know the answer, we'll direct you to resources that give a really good explanation of what you're still wondering, or we will tap some of our colleagues in other departments at the university or at other institutions from people that we've worked with or people that we know the answer to your question. So get to it.